And yeah, I hold multiple certifications actually. So on the DevOps tools, and yeah, and I started my teaching career from past 4 years actually. So that's what my short introduction about myself. And today webinar is all about the AWS Lambda in production actually. So how we can optimize the performance in AWS Lambda functions. And like we will be going through lot of concepts of AWS Lambda and its invocations and its integrations and multiple things actually. So before moving further, let me share my screen and I will be just placing all the points that we are going to go through in the today's class. Okay, let me share my screen. Okay, let me know if my screen is visible, guys. Is my screen visible for everyone? Is my screen visible for everyone, guys? Yes. Okay, that means my screen is visible, right? Thank you. Okay, so let me just go to the paint and just put all the points that we are going to, let's just put all the things that we are going to discuss as part of the today's class. Okay, we will be starting with why lambda. Just let me just put that points here. That's the thing that we are going to discuss. Okay, so just let me put it here. Okay, agenda for today. What's the agenda for today is going to be? Okay, let me put that one here so that you will be understanding why. Okay, why lambda? Okay, we need to use lambda over EC2 machines actually. So that's what it is. Why lambda? Why AWS lambda? Why AWS lambda? And you need to also understand intro to AWS lambda, intro to AWS lambda, AWS Lambda, guys. And the next point that we are going to understand is Lambda function invocations. Lambda, Lambda function invocations. We'll be understanding each and every point very in a very clear fashion in the diagrammatic way. And as part of the Lambda function invocations, there are two ways from which we can invoke the Lambda function. One is synchronous invocation, synchronous invocation. Okay. And there is asynchronous invocation, guys. Asynchronous. Asynchronous invocation. Asynchronous invocation. Okay. These are the two types of invocations that we are going to see actually. And then we will be understanding different configurations that we can do as part of the Lambda configurations. For example, configuring CPU or memory and configuring the timeout, configuring like concurrency and what is reserved concurrency, provision concurrency, multiple environmental variables configuration, and multiple things where we are going to see the configuration as part of that. And we are going to see the security stuff like we have a resource based policy and IAM role that we can attach actually. So security, so RITY security, and we will be understanding how to understand how to monitor the lambda function, monitoring lambda function using their dashboards that they have given actually. So that's what it is. And we'll also see optimizing optimizing lambda function performance. Okay. Function performance, guys. Okay. So, and we will be ending the session with the Q&A. So these are the different topics that we are going to see as part of the today's class. These are the different topics that we are going to see as part of the today's class. If the time permits, if the time permits, guys, for me, I can also include layers as well, and I can also include aliases and versioning as well. Based on the time, we will be including the things. into this particular agenda. Okay, that's what you need to understand from the pointers. Okay, so let's move forward. Let's move forward with this particular agenda as of now. Actually, suppose now for this, in order to do the labs, actually after this particular with after this session, you need to have an AWS account. That is a prerequisite for you. You need to definitely have an AWS account. That's what the a small prerequisite actually. So that's what it is. So suppose, let's say let's go with one by one as part of this. This is as part of the agenda. Okay, let's go with one by one. Okay, now let's say you have an application, guys, and you have a developer who developed the application. Let's say this is a developer who developed the application, for example, something like this, and he developed a application, for example. uh, it's a very small application, and it is he's like, see, this is a small, this is an application that he has developed, and he has written some code as part of this. For example, something like this. It's something like this, and this is the application that this guy developed as a developer. Now, so this is a developer, and this is the application that we have developed. Okay, this application, this application can be deployed in EC2 machines, and this application can be deployed in AWS Lambda. Okay, this application, whichever the developer develop, this application can be deployed in EC2 machine, and this application can be deployed in AWS Lambda. Okay, so like let's see what are the disadvantages of using or deploying this application in EC2 machine, guys. Let's say this guy has deployed this application in the EC2 machine. Let's say this is the disadvantages of deploying application on the EC2 machine. Disadvantages of deploying of deploying this application in EC2 machines. Okay, let's deal with this actually. So let's first understand, okay, what are the disadvantages of deploying the application on EC2 machine. Okay, let's understand. If this application is not going to get a regular request, actually, so that's what you need to understand. Okay, so the first disadvantage is you need to continuously run the servers. You need to continuously run the servers if the incoming requests are there or not. Okay, you need to understand, if you deploy this application on the EC2 machines, whichever the developer developed, what will happen is, even though there are no people accessing this application, you need to continuously run that particular application. Your server need to be continuously running, so that whenever the new request comes, something is there at the server side which is going to accept the request. So that is the first disadvantage that you have in deploying the application on the EC2 machines. What is the disadvantage? Is even though the traffic is not coming, you need to make sure that your application is always running. That's what the first disadvantage actually. So continuous running, even though there is no request, continuous continuous running of the application, running of the machines, even though there is there are no incoming requests. Okay, that's what you need to understand. Okay, continuous running of the machines where our application is deployed, even though there are no incoming requests. So because of this, what will happen? Because of the continuous running of the machines, even though there are no incoming requests, what will happen? You need to pay the cost for the machines that you are running in an because you need to pay the cost for the machines that you are running. Okay, it is not serving your business, but you need to pay that. Okay, because you are running the servers and your application is deployed on that servers. Actually, that's what that's the second point. The second disadvantage of uh, using uh, EC2 machines whenever you want to deploy the application. Actually, so need to pay to the servers. Okay, need to pay to the servers that we use, even though they are not adding value to the business, because they are not adding the value to the business, even though, because the application is deployed and it should be continuously running on the servers, and server should be continuously running even though the requests are coming or not. Okay, if these requests are not coming, also the server should be continuously running on which your application is there. Okay, and for that server, okay, even though the server is not serving the request, it should be continuously running and you should pay for that, right? That's what the point that I have mentioned it there. Need to pay to the servers that we use, even though they are not adding a value to the business. That means they are not serving the traffic. That's what you need to understand from the point. Okay, that's what you need to understand. So you need to configure. You need to additionally configure additional 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 configuration need to be done to scale the servers. Okay, that's what you need to understand from the point. So in the auto scaling groups of the EC2, if you deploy your application on the EC2 machines, you need to do some configuration. If my CPU utilization is this much, it should automatically scale it. Okay, or you should manually increase the number of servers, the desired capacity at the auto scaling group. Okay, you need to increase the desired capacity so that your servers can scale if there is huge number of traffic coming to your application. So this is the manual activity that you are going to do, or you are going to do some configuration like scaling policies in order to scale your servers. Okay, additional configuration need to be done in order to scale the servers. So this is the additional burden on us in order to perform scaling if you are deploying the application on the EC2 machines, guys. EC2 machines. That's what you need to understand from the point. Okay. The next point is, if this is limited CPU, if you deployed application on the EC2 machines, that will be having limited CPU and memory resources. Memory resources. What is this limited CPU and memory resources? I'll be talking about that. What is this limited CPU and memory resources, guys? Limited CPU and memory resources means, see, if you are deploying, for example, the application in the EC2 machine of T2 dot medium size of the machine, type of the machine, instance type I'm talking about, right? That machine is going to get only two CPUs and 4 GB memory. Okay, that's what you need to understand. Whenever you want to deploy this application on the T2 dot medium type of machine, that machine is going to get only two CPUs and 4 GB memory. Your application cannot use beyond these two CPUs and 4 GB memory. Okay, that's what the limitations that you have if you deploy your application on the EC2 machines, guys. That's what you need to understand. That's a limitation, right? If your application wants more than two CPUs and 4 GB memory, it cannot use, because the machine itself has two CPUs and 4 GB memory. Your application cannot use more than that, and your application will be affected. So that's a next disadvantage of if in order to deploy your application on the EC2 machines, actually. So that's what you need to understand. Let's stick to this. There are disadvantages, something like this. Okay, this is the disadvantages of deploying applications on the EC2 machines until and unless there is a special use case. Actually, that's what you need to understand from the part. Okay, so is these points clear, guys, for everyone? Are these point clear? let's move further with this, how the Lambda functions is going to solve these problems. Okay, so like these are the serverless functions, guys. These are the serverless functions. It does not mean the servers will not be there. It means that we are not going to manage the servers. That's what you need to understand. Internally, whenever you deploy a Lambda function, whenever the Lambda function is getting executed, it is going to be running on a server only. But that server we do not manage. It is entirely managed by AWS, and we are not responsible for that actually. So now let me just put that one here. These are the AWS Lambda. Let me put, because of these disadvantages, it's good to run your application as part of the AWS Lambda. So let me put AWS Lambda. Okay, so that's what you need to understand from the point. So what is this AWS Lambda, guys? AWS Lambda are the virtual functions, okay, functions with no servers to manage. No servers to manage. That means it does not mean there are no servers, but we do not manage the servers actually. That's what you need to understand. Okay, so servers are there. AWS uses the servers internally. What is that? In order to execute this Lambda function code, actually, that's what you need to understand from the point. Okay. The next point about the Lambda function that we need to understand is they are limited by time. They are short executions. Actually, suppose you can, if your application is, if your code is running more than 15 minutes, you cannot run your that particular code as part of the Lambda function. You need to run as part of the different places actually, or forget ECS, forget or EC2 mission, something like that. You are in the Lambda, you are limited to make the code to be executed within the short duration of time, with from 3 seconds to the 15 seconds, that's what, 15 minutes, that's what you need to understand. So that has limited by time, that is limited by time, guys. Okay, that's what you need to understand. You need to use the Lambda function for short executions, short short execution of the code, short executions of the code. That's what you need to understand from the point. Okay, so they are, see, here we no need to, if you use Lambda functions, you no need to make the servers to be continuously running. They will be executed on demand. Whenever the request comes, then only internally the server comes up and the Lambda function get executed actually. So they will be executed. They will be running on demand, guys. Okay. Whenever the request comes only, that will be running actually. So it will not be keeping on running like EC2 machines. They will not be keep on running like EC2 machines. They will be running based on the demand, or based on the request actually. So that's what you need to understand from the point. They runs these lambda function, okay, executes code based on demand, guys. Demand, based on the demand. They will not be continuously running like EC2 machines. They will be coming up whenever someone send the request to the Lambda function, or someone triggered the Lambda function. That's what you need to understand from the point. Okay, here scaling is automated. You know of doing any configuration. You know of doing any configuration, guys. So based on the incoming request, automatically the scaling is going to be happening. The scaling is automated, guys. The scaling is automated. You not of manually scale, or you not of doing any configuration in order to scale the executions of the Lambda function. Okay, the scaling is entirely automated if the incoming requests are getting more, and more number of executions of the Lambda function is going to be happening. For example, let me just go to the Chrome browser, and let me just go to this place, and let me just go to Lambda. Okay, just for example, let me just go here. So this is how the Lambda screen looks like, guys. And just let me go to slash begin. If you see, this is the begin screen actually. If you scroll down, okay, no, not here. I think, yeah. Where is that? Okay, so you can see that here. So how it works? This is the Lambda function. You can see that here. This is a Lambda function that is, you can see number of, based on the triggers, the number of executions will be automatically scaled. Guys, if you are seeing this one, you can see that here. Automatically scaling is going to be happening actually. So you're not of configuring anything actually. So that's, you can very clearly see this actually. So that's what you need to understand. So scaling is automatically automated. You're not doing any configuration, or you're not doing anything, to make the Lambda function to be scaled. Whenever the triggers are happening from the different places, it can be from IoT devices, it can be from streaming analytics, or it can be from data processing S3 buckets, whatever it is. So they are automated. They are automated. Scaling, the number of execution of Lambda functions is going to be automated, guys. This is very good UI. So, to explain the scaling of the Lambda function, you can just see that here, based on the events that you are passing to the Lambda function. So the Lambda function scales actually. So based on that, okay, if the events are decreased, Lambda function scale down. Okay, like that. Okay, that's what you need to understand from the point, guys. So this is the things about the Lambda function. These are the few things about the Lambda function before moving further. I hope everyone is clear with this. One second, guys. Anyone have any questions? You can put your messages in the chat. Anyone have any questions? Is that clear until here, guys, for everyone? Please, is that clear for everyone until here? Please respond. Yeah. Okay. 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 So let's move to the next point, guys. Let's move to the next point. Okay. So that's what you need to understand. So yeah, it's a horizontal scaling, Sairaj. Yes, you are right. It's a horizontal scaling that is going to be happening. Okay, you can see that very clearly here. The executions are going to be scaled horizontally. Okay, that's what it is. Okay. Yeah. Now let's move forward with this, guys, and let's understand the next point actually. So who can trigger? In what ways the Lambda function can be triggered, guys? Okay, the ways that the Lambda function can be invoked, triggered or invoked, both are same. That's what you need to understand from the point. Okay, ways that the Lambda function can be invoked. Okay, so different ways that that lambda function can be invoked actually. So the first, like, the way, like, this is a base actually, so you can see that, understand from the point. And the first way is using synchronous invocations. The Lambda can be invoked synchronously. We'll be understanding what is synchronous invocation, guys. Synchronous, just wait for the point. Synchronous invocation. Okay, synchronous invocation. See, what is this synchronous invocation is, suppose there is a Lambda function. Okay, suppose there is a Lambda function. Okay, for example, file. Let me take a new diagram part. Okay, suppose there is a Lambda function, guys. This is a Lambda function. Let's take actually. So this is a Lambda function that we have created in the console. Okay, and this let me label it. Okay, this is the Lambda function that we have created in the console. So what is this synchronous invocation means? Suppose if you are sending, suppose this is a Chrome browser that you have. This is a Chrome browser that you have. Okay, let's say this is a Chrome browser that you have. This is a Chrome browser that you have, guys. Okay, so if you are sending the request from the Chrome browser, if you are sending the request from the Chrome browser, okay, if you are sending the request from the Chrome browser to the Lambda function, so you should wait, the Chrome should wait until the Lambda function respond back. Okay, until the Lambda function respond back. This is something called synchronous invocation. What is synchronous invocation? The the waiting of, whenever you send the request to the Lambda function, you need to wait until the Lambda function responds back to you actually. So that's what you need to understand. This is synchronous invocation. This is synchronous invocation actually. So this is synchronous invocation, this. Okay, that is the thing. Now, what is asynchronous invocation? This is synchronous. Let me put synchronous. Synchronous invocation. For example, this is a one. This is synchronous invocation. Okay, you should be in sync with Lambda. Okay, your client here, Chrome, should be in sync with Lambda. That's what you need to understand. So now, what is asynchronous invocation? Let's say you have a Lambda function. You have a Lambda function here. This is the Lambda function that you are going to have. So, for example, you have a S3 bucket, which is going to trigger the Lambda function. Let's say this is a S3 bucket, which is going to trigger the Lambda function, guys. Okay, so let me put this one Lambda, Lambda, and this is the S3 bucket, S3 bucket, guys. This is the S3 bucket. Okay, so now let's say your S3 bucket is triggering the Lambda function. So S3 bucket don't care whether the Lambda function is successfully executed, and S3 bucket will not will not wait or will not see for the response from the Lambda function. This is something called asynchronous invocation. They are will be not in sync. Just S3 bucket. Suppose, for example, whenever the file is uploaded into the S3 bucket, automatically your configuration you will be setting in such a way that S3 bucket is going to trigger the Lambda function. Okay, S3 will not be knowing here whether the Lambda function is successfully executed or not. Okay, just it will trigger, that's it. But here Chrome will be knowing, in case of synchronous invocations, the Chrome will be knowing that whenever your Chrome is invoking the Lambda function, if the Chrome will wait for the response back from the Lambda function. That means if the Lambda function is not executed successfully, your Chrome will show the error, will be showing with the error. That is synchronous invocation. That is, Chrome will be knowing here that the Lambda function did not executed correctly. But here, the asynchronous, they will be in sync with each other. That is something called synchronous invocation. Chrome and Lambda function will be in sync with each other. But in this case, the S3 bucket and the Lambda function. So here, so whenever an object is uploaded into the S3 bucket, automatically the Lambda function is going to be triggered, and S3 don't care about whether that particular Lambda function executed properly or not. S3 will not get that info whether that particular Lambda function is executed perfectly fine or not. Okay, so S3 just triggers the Lambda function and Lambda function will be executed. Okay, that's what you need to understand. This is, they will not be in sync with each other. That's what the meaning of it. That is something called asynchronous invocations. Okay, asynchronous invocations, guys. Okay, asynchronous invocations. Asynchronous invocations. That's what you need to understand. Those are the synchronous invocation, and this is nothing but a asynchronous invocation. That this is nothing but a asynchronous invocation. That's what you need to understand from the point. Okay, let me just divide these boxes something like this so that you will not be able to, you will not be confusing. Just let me put something like this, guys. Okay. Now, the next part, which are the services that will trigger the Lambda function synchronously, and which are the services that will uh, 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 trigger the Lambda function asynchronously. Let's list some of the services actually. Just let's list actually. So, for example, let me just go to the point. Okay, so services synchronously. Okay. So for example, you will be having load balancer, application load balancer, like I can say, or whatever the load balancer in AWS. We'll be seeing some demo on this actually, load balancer. And you'll be having something called API gateway. Okay. This is synchronously invoked, and cloud front. Okay, for example, these are the services that you can understand. Synchronous invocation means the client from where the Lambda function is getting the request, and the Lambda function will be in sync. The client will be knowing whether the Lambda function is successfully executed or not. That is something called synchronous invocation, guys. Synchronous invocation. Okay, that's what you need to understand from the point. Okay. Uh, 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 I'll do that, Ranji. Just give me some time. Okay. I'll be doing that. Okay. So now now what is a synchronous invocation? So the client from where we are sending the request will be knowing uh that knowing the status of lambda function execution. That's what you need to understand from the point. That's a synchronous invocation. Okay, the services, for example, I have put that services which can synchronously invoke the Lambda function. That's what you need to understand from the point. Now let's deal with the practical scenario of synchronous invocations, guys. Okay, just let me go to the Lambda function. Okay, let me just go to the Lambda here. Just go here. Okay, so let me just click on Lambda function. What is my architecture diagram for this synchronous invocations, guys? Let me draw the architecture diagram as well so that you will be able to understand the points that we are discussing. Let me just draw the architecture diagram, how we are going to synchronously invoke the Lambda function now. For example, you see that here, this is the Lambda function that we are going to create in the AWS account. And we are going to, this is the Lambda function, and we are going to attach this Lambda function to the target groups. For example, this is a target group that we have, and this target group, it is going to be attached with this particular Lambda function. So that target group is going to route the traffic to this Lambda function, guys. This is the target group. Okay, target group is one of the resource in AWS target group. Okay, that's what we are understand from the point. Okay, now this target group is going to be integrated. We are going to integrate this with the application load balancer. For example, this is the application load balancer, guys. Okay, this is the application load balancer with which we are going to integrate the target group. This is the application load balancer. Okay, let me just go here. This is the application load balancer. Application load balancer. Application load balancer. That's how it is. Okay. So now this target group is going to send the request to this particular Lambda function. For example, this one, right? That's how it is going to work. Okay. So and uh from the browser, from the browser, this is the browser that you have, guys. This is a browser. Okay. This is a browser. I am unable to draw it here because I need some space, guys. What I'll do, I'll just copy this to the new paint page. Let me just copy this file new. I'd like to put it here. This is the diagram that we are drawing. Okay, that's what you need to understand from the point. Okay. Now, this is the browser that we are going to have. This is a Chrome browser. Okay. So whenever you create a load balancer, you are being allocated with something called DNS name for the load balancer, guys. You are allocated with some DNS name for the load balancer. So this is the browser. This is a browser of Chrome. That's what you have to understand from the point. And from this Chrome browser, your HTTP request is going to be reaching to this load balancer. Okay, your HTTP request is going to be reaching to this load balancer, guys. Okay, when the communication from the browser and the load balancer will be through the HTTP protocol, guys. HTTP protocol, HTTP protocol. Okay, you need to understand from the point. And you need to understand whenever the load balancer is going to request, like whenever the load balancer is going to receive the request, this one load balancer will contact the Lambda function by converting this request into a JSON format. Okay, this one will be converted into a JSON format, guys. That's what you need to understand. I'll talk about what is that, what will be there as per the JSON format. We'll be seeing that, but yeah, this is how the things works whenever they are synchronously invoked. Okay, here the Chrome will be waiting for the response from the Lambda function. Okay, as per the Chrome stream. Okay, that's what you need to understand from the point. Okay, so that's how the architecture diagram is going to look like for our synchronous invocations, guys. Before moving in the practical, I would like to provide this architecture diagram actually. So let me just go to the Lambda. Okay, so just let me click on create a function. Just click on the create a function, guys. I'm creating the function from the scratch. Okay, so I would like to uh, provide the function name sync sync with load balancer. Well, load load balancer, guys. Sync load balancer. That's what I'm just writing the function name, and I'm going to use the Python version 3.12. Sorry, that's a uh, 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 no. There are some applications where you need to run the applications on the EC2 machine only. Okay, Sairaj. Okay, that's what the different case actually. So uh, in that case, you need to have the target group with the EC2 machine. Okay, so that's what it is. So now we are saying we are configuring the runtime with Python 3.12 and the architecture is x86 underscore 64. And let me click on create a function, guys. You can just see that here. This is going to be the create. This is going to create a function. We can just refresh it. Once again, it is going to create a function, guys. This we need to wait. It's wait of time. Okay, you can see that here. This is the function that got created. And what you can see that here. This function is, you can see just what it is doing. It is just, you can see that this is getting printed as per the console. It is going to be written this one actually. That's what it is. And let me just click on test actually and create new event. I would like to create an event. We'll talk about the event actually, so no issues with that. But yeah, what is an event? The event is an input that is received by the Lambda function. And let me just click on save. If you see that here, this is the event. And let me click on test, guys, and you will be executed with your Lambda function response. You can very clearly see that you are getting the response which you have, which is written by your Lambda handler. You can see that here. Okay. What is the Lambda handler? Whenever the what Lambda handler is a function, Lambda handler is a method. Okay. So whenever your Lambda function got triggered, this particular method will be executed. Actually, that's what you need to understand from the point. That's a Lambda handler, guys. Okay. Now now let's integrate this with the what is that? Target group. Let's integrate this with the target group actually. So let me increase the font if that is okay. So yeah. Uh, okay. Let me just go to the EC2, guys, for creating target groups. Let me just go here and let me just go there and let me just click on that and let me go to the target groups. Okay. Let me just go here and I would like to create a target group. Come on. Who created all these things? If we delete this existing thing, guys, I'm not sure. Think someone created this one. That's fine. So let me click on create a target group, guys. Okay. Like where this target group should send the request to the Lambda function. You can see that here it's a Lambda. You need to select the Lambda function and the target group name. I would like to give it as invoke in invoke invoke Lambda. That's for the target group name that I would like to give. And let me click on next actually and select the Lambda function that you have created here, sync load balancer. And that's the latest version that I'm going to trigger actually. Just let me click on next and let me click on create a target group. Create a target group. I'm just clicking on creating the target group, guys. I'm just, you can see that here, this is the target group, which is going to be the target is this particular Lambda function that we can very clearly see as part of this particular thing, right? So the next thing, you need to create a load balancer, guys. Click on this load balancer and click on create a load balancer and create application load balancer. It's an internet facing load balancer. Okay, so invoke the like the load balancer name is going to be the invoke invoke lambda LB, guys. That's what the load balancer name. It's an internet facing load balancer. I'm going to deploy this in this particular VPC. It's a default VPC, and just I'm going to deploy this in the US East 1A subnet. That's a default subnet that we have. And I'm not sure because this is okay. Let's see. Okay, and I would like to create a new security group instead of using this existing one. Okay, so just let me go here. Uh, Lambda invoke Lambda SG and Lambda SG, guys. And just let me click on this VPC and just that's a VPC that we have. And I'm going to add inbound rule all of the HTTP traffic because we are going to send the HTTP request to this load balancer. Okay, let me click on create a security group, guys. And just let me go to the load balancer screen and let me refresh this one here, and it is going to give you the another security group that we have created. Okay, now you can see that here this is the protocol port on the load balancer that we are getting listened actually. The load balancer is listening and it will click on invoke lambda function as a target group. Right. Let me just scroll down and let me click on create a lambda function. Yeah, that's a problem. I know that. Okay, so you see that here we have only one subnet that is as part of this particular VPC. So I need to create one more subnet, guys. This is not in the scope of a webinar, but yeah, I need to do that. Without doing that, I cannot actually. So just let me go here to the uh, subnets. This is the default VPC. That's what it is. Subnets. You can see that here. This is a default subnet that only exists. And route tables. You can just click on this. What is that subnet that is in there? Subnet associations, and this also won't work. Yeah, root routes. That's fine. So cancel this one. And I would like to create subnets. Click on that. And this is part of the VPC 8199. And let me just create one more subnet, guys, with this particular uh, range. Click on create a subnet and select the 8199. And let me just create subnet 2. And available zone preference is going to be the 1B. And this is going to be this one with 1.0/26. That's what I would like to create. And let me just click on create a subnet. Okay, that's fine for me. Now this subnet is going to be added to the route tables, subnet associations, edit subnet associations. I would like to add this to the route tables, guide subnet, save associations. Okay, just that's what it is. I'm just creating the subnets and associating them to the route table. Okay, so the routes are being proper and the thing. Now let me go to my load balancer. This is not in a scope, guys, but yeah, we should do that. The people who understand the AWS will be understanding about that, but well, yeah. So just let me again refresh this screen. Invoke, invoke Lambda LB, right? So just let me go here. This is a VPC and these are two subnets that I'm going to select. Okay, and that is a one. And the security group is this one, which we have created. And let me just go to the target group selection from where we have integrated with our Lambda function. Correct. And let me just click on create a load balancer, guys. Okay, you can see that here load balancer got created and it is getting provision. You can just notice that that will be soon uh, being invoked. Let it provision completely. Okay. So meanwhile, you see that here your Lambda function is properly working, and this is how you can just uh, this is the architecture diagram that we have discussed. The Chrome, we are going to send the HTTP request to this target, like load balancer. Load balancer target group is registered with the Lambda function, and this Lambda function is going to be triggered by this particular load balancer in the JSON format. Okay, this JSON format, if you want to print, we can print it as part of this place. Actually, so we will wait for that to be executed. Actually, so we'll see. Okay, so okay. So if any issues comes, I'll also help you how to debug that. So let me just go here and just check whether this is got provisioned or not. Let me just see. Yes, it is getting provisioning. Okay, still. And yes, you can see network mapping and all those things. Resource map is going to tell you. You can see that this rule, which is this listener, which is attached to the load balancer, is forwarding the request to this particular target group, which is invoking the Lambda function. A target rules is this one, and target group is this one. And this is the target. That's the Lambda function. Okay, that's what you need to understand from the point. Right? Now let me just go here, guys, and let me try. Okay, let me copy this DNS name, put this one here, HTTP colon slash slash on this one. Click on enter. Okay, so this is not giving the response. Let's wait for that. Okay, let's just wait. Hmm, because it's in the provisioning state still. Yeah, it is in the active. Let's check what happened. 1 second, guys. HTTP TP colon slash slash and let me click on enter. So this is not getting okay. So let me first check how to debug that. Is you need to first go to monitoring and you need to check whether the requests are reaching to this particular place or not. Just let me see the request coming and let me just to go to the local time zone. Okay, just let's refresh. Yeah, you can see that here requests are coming here. But location lambda function is 0. Okay, let's see. Okay, what we'll do, we'll go to the Lambda function, just go there and let's go to the monitor and check whether the invocation has been there. Yeah, it is there. You can see that here. But what is that is invocation is ours actually. So once again, it is not from the load balancer. It is from our test event actually. So that's what it is. And just let me close this and let's see if the logs are being populated with the load balancer. Okay, just let's see about the logs. There should not be any problem, but let's just, it's a matter of taking time. Okay, you can see that here it is just, it's not a load balancer thing. It's a, it's not a load balancer thing. It's a manually we have invoked the Lambda function. That means the invocations are not getting reached Lambda. So just let's wait. No. So this is the requests that are coming. No, nonsense. Okay, let me go here again, just try to invoke this. Yeah, you can see that here. Actually, it is a matter of taking time. You can see that here it is downloading the file. You can see that here it is downloading the file. That means our Lambda function is getting invoked. You need to wait some time in order to the request to be propagated. Okay, so now let me just save that file. Okay, just save that file, and let's see what is there as part of that particular file actually. So let me down. Okay, come on. Okay, you can also access this particular function, and there will be some file downloaded to you. Let me just put that one endpoint for everyone. This is a Lambda function. Sorry, load balancer ARN that will be downloaded actually. Let me click on save actually. So let me check what is there as part of that particular file. You can go to the downloads and you can see that it is downloading. Okay, Chrome is Chrome is detecting that this is a what is that? That's a What is that? Yeah, you can see that here. Chrome is saying that it is an insecure download block. If it is blocking the download, you can very clearly see that here. What we'll do, we will make the Lambda function to return good response actually. So I'll do, I'll just copy this. There is a content. You can just copy these things from this particular place. Okay, this things. Let me copy this particular response object and let me go to the Lambda function and make this Lambda function. Let me just refresh. Yeah, you can see that here invocations are happening in the Lambda level. You can just clearly see that invocations are happening from the load balancer. Okay, so this is synchronous invocation. Okay, that means you are waiting until the Lambda function is responding, right? That's what it is. Let me just put these things here, guys, and let me just give some space here and make the indentation to be proper. And you can see that here, just to give some space and just give some space here. And just let me just go here. Okay, that's what it is. And let me deploy this Lambda function. Let me deploy this Lambda function. It is going to be deployed. And you can just again request from this browser. Click on enter. It is going to show you some hello from Lambda. Why it is showing hello from Lambda? Because you have written this particular body in the HTML format. So this is a synchronous invocation, guys. That means you are waiting for the Lambda function to get responded, and you from the browser is waiting for that. So whenever the Lambda function is been failure, you will be immediately notified here actually. So you will be knowing that your Lambda function is not getting properly executed actually from the browser. So this is something called synchronous invocation. From your You will be knowing that your Lambda function will got is got has some problem actually. That's what you need to understand from the point. This is something called synchronous invocation. Okay, synchronous invocation. That's what you need to understand from the point. Okay, is this clear, guys, for everyone? Yeah, there. See, whenever you have attached a Lambda function to the target group, we'll talk about the security that comes under security part, the roles and resource-based permissions, resource-based policy. You just go to these permissions. Okay, your load balancer is automatically allowed, okay, to access this particular Lambda. Okay, that's what you need to understand. Just we'll be talking about that soon. You can see that here your load balancer is allowed at the resource-based policy. Who should invoke the Lambda function? You can very clearly see that here. Okay, we'll be talking about that soon when we talk about the security, guys. Okay, so is this thing clear for everyone, guys? Yeah, I would like to share the Lambda code if you want. Just let me go here and just let me copy this Lambda code that you want and just let me put it in the chat if you. Okay, this is the Lambda code that I've used. Okay. Okay. So Now, the next point is uh, I have told you in the architecture diagram, whenever the Chrome is sending the request to the target group, Chrome is sending the HTTP request. You people know because the target group is listening on the HTTP protocol on port number 80, right? And this one, the request from the load balancer is going to be sending the request on the JSON in the JSON format. Okay. Now we will be understanding what this target group is sending the Lambda function in a JSON format. So for that, see, we need to print an event. What is this event, guys? Event is an input that need to be that is get that will be passed to the Lambda function whenever the Lambda function is getting invoked. Okay, here Lambda function is getting invoked by this particular target group. Target group is going to be passing some input to this particular Lambda function. That is nothing but a event, guys. The event holds the input that we that is passed to the Lambda function whenever it is invoked actually. So if you just print the event, print of event, guys. Let me print the event, event. Let me print the event. And let's check what the target group, what content in a JSON format that the target group is sending to the Lambda function. Okay, I've just printed the event. Let me click on deploy. Okay, let's deploy it. Okay, so okay. So now let me again trigger the Lambda function using load balancer endpoint. If you click on enter, so you are going to get the hello from Lambda, and this particular print, whatever you are printing the event, okay, will be displayed as per the logs. Let me just go to the monitor, view logs in the CloudWatch, and you will be able to see the logs in the CloudWatch, guys. You can just click on this one, right? And you will be seeing the logs. You can see that here. This is the event that the Lambda function is, sorry, that the target group is sending. Okay, you just need to just go to the, that's a JSON format event. Let me just go here. Okay, JSON editor. Let me just go to the JSON editor, online JSON editor. Let me remove it and put it this one here. Let me uh, expand all, for example, I'm going to just copy this one and go to some VS code, right? So let me just control N, and this is a one guys. Okay, this is the content that Lambda, like target group is sending. Target group is sending the event to the Lambda function whenever it is getting invoked. You can see that here. It is also sending our browser name, what is the type of browser that we are using, and how we have invoked our Lambda function, something like this. And this is you can see that here, host. Okay, and it is sending lots and lots of stuff to on what port we have invoked and what protocol. And you can see it is also sending my IP address to the Lambda function. You can see that here. My IP address is also sent to the Lambda function, guys. You can just very clearly see that. Okay, so as a request, my IP address also is going to be sent actually. So you can just see that actually. So, uh, guys, okay. So, uh, one second, guys. Okay, let me show you what is my IP address. Okay, let me just go here. What is my IP address? Like, click on that. You can see that here 45.112.185.57. Right. You can just see that particular output 45.112.185.57. Right. You can see that here 45.112.185.57. This is the IP address that is sent to the Lambda function from the target group. Like it is also sending the IP address. You can see that uh, 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 how logical it is thinking actually. That's what you need to understand from the point. So these are the lot of stuff that is being sent as an event to the Lambda function whenever it is triggered. So that means you can just see that one here. Whenever the Chrome is invoking the target group in the HTTP request, that HTTP request is going to be converted into the JSON format and sent as an input to the Lambda function as part of the event, guys. Okay, that's what you need to understand from the point. This is how synchronously Lambda function can be invoked, not through only load balancer. One of the synchronous invocation ways the load balancer. You can just invoke the Lambda function synchronously through the CloudFront, through the API gateway, through the Cognito, to the AWS step functions, multiple ways with which you can invoke the Lambda function synchronously. Does that's what you need to understand from the point. Okay, that's what it is. Okay, so now let's move to asynchronous invocations, guys. Asynchronous invocation. This is a diagram for synchronous invocation. This is a diagram for synchronous invocation. Invocation, guys. Okay, that's a diagram for synchronous invocation. Just let me just put it here. Okay, so now let me just move this to the top so that I can draw another diagram with the asynchronous invocation. Okay. Here, let me draw the diagram with asynchronous invocation. Let me just, okay. So for the asynchronous invocation, what we are going to have is we are going to have the S3 bucket, guys. For example, this is a S3 bucket where we are going to have, just let me just put it here, S3 bucket. Okay, for example, that one. And this is the Lambda function that we are going to have, guys. Okay, that's what we need to understand from the point. That's what we are going to understand. This is a Lambda function example. Okay, so uh, Lambda function. This is a Lambda function. Okay, that's what it is. Now, whenever an object is uploaded into this S3 bucket, object means or file or something. Okay, you will be uploading some object into this S3 bucket, guys. Whenever an object is uploaded into this S3 bucket, okay, for example, some file or some data or something, you will be uploading the data into the S3 bucket. Your Lambda function is going to be triggered, guys. Your Lambda function is going to be triggered. And here, S3 will be not be knowing whether the Lambda function is executed properly or not. Here, S3 will not be knowing whether the Lambda function is executed properly or not. Uh, 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 it will be just triggering the Lambda function, and that's it. That will do that thing only. It is not going to uh, 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 do anything. Just it triggers the Lambda function whenever it is. Okay. Now, this Lambda function, you can configure this Lambda function. If the Lambda function is failing to execute the code, which is there in the, which is asynchronously invoked, you can make this Lambda function to retry multiple times. You can make this Lambda function to retry multiple times. For example, number of retries you can give actually. So, okay, you can make this Lambda function to retry multiple times for the same event. Even after the retry, the Lambda function is getting failed. What you can do is you can send that particular invoked event to the SQS queue. It's a dead letter queue, so that someone is going to process that event and check why that particular thing is being failing actually. So this is something called SQS queue, to which you can send the Lambda function failures. Even this is a SQS queue. Just think that one as SQS queue. I'm just let me put it here. This is a SQS queue, guys. SQS. That's what the thing is. And this is the retries that you can do whenever the Lambda invoke the Lambda function, asynchronously invoke the Lambda function, failed to execute. You can configure the Lambda function to retry multiple times. If after execution of the Lambda, retries of the Lambda function, still if it is failing, you can put that particular event into the SPS queue, and you can, some other process will be seeing that particular SPS queue publish messages, and that will utilize whatever that one that you can do actually. So this is something called retries. The maximum number of retries that you can do is 3, guys. Okay, that's what you need to understand. Retries, you can just make configure it. Okay, that's what you need to understand from the point. Okay, so is this architecture diagram clear, guys? Is this architecture diagram clear below one? Everyone, please, is this architecture diagram clear for everyone? Yes. Okay. Thank you. So now this is the asynchronous invocation. Before achieving this architecture diagram, guys, what we'll do, we will see asynchronous invocation means whenever this is how asynchronous invocations this is how asynchronous invocation will be happened actually. So whenever some file is uploaded into the S3 bucket, that particular file is going to be that particular event is going to trigger the Lambda function. And S3 will not be knowing whether this particular Lambda function is executed successfully or not. S3 just triggers the Lambda function. That's it. It will not be knowing whether that particular function is successful or not, whether that function is successfully executed or not, failed, like it is being failed or not, whatever it is. S3 will not be knowing about it. Okay, that's what you need to understand from the point. Lambda function will be like will be executing the code whenever the trigger has been happened from the S3, and that particular Lambda function, if it is failed, it is if you configure the retries, Lambda function will be retried for some certain amount of retries. If it is still failing, that particular event is going to be placed in the SPS queue, guys. That's what you want to understand from the point. Okay, that's the thing. That's how asynchronous invocations is going to work. Here, whoever invoking the Lambda function will not be. What is asynchronous invocation? Whoever invoking the Lambda function will not be knowing whether the Lambda function is executed successfully or not. That is something called asynchronous invocation, guys. Okay, that's a point. Right. Now, let's it's like before achieving this particular scenario, guys, we will be configuring the like we will be triggering the Lambda function using our Cloud Shell using asynchronous invocations. Let me just go to that particular uh, Chrome browser, and let me just go here and let me just go to that particular place. Functions. Okay, let me create a function async 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 CLI, guys. I'm just printing async CLI. Okay, that's what I'm just using the Python 3.12 version. Okay, just let me go here and let me just go to the create function. Okay, so that's what it is. And let me click on create a function and it is getting created. You can very clearly see that. And just let's wait for that. Okay, so let me click on dismiss and let me just go to the Cloud Shell. Let me go to the Cloud Shell, guys. There's a Cloud Shell that we have. Yeah, here it is, Cloud Shell. You can see that here. The Cloud Shell is here as well as here as well. Wherever you want, you can go just click on this one. So you have opened with the Cloud Shell of your AWS account. Okay, so just it is getting connected. Okay, so what's the function name that we have? Async CLI, right? That's what it is. Okay, so it is getting the problem actually. So that's what it is. So I cannot now, because you can see that here it is unable to create an environment. Your account is verification is in progress. This may take up to 2 days to for new accounts. If you have any further questions, contact us and to retry that. So I'm able to create it this Cloud Shell, but I'm going to give you a command, okay, which is going to be asynchronously invoking the Lambda function so that that command is not going to wait for the Lambda function to be executed properly or not, whether the Lambda function is getting executed properly or not. Okay, that function is going to just trigger that particular command is going to trigger the Lambda function. That's it. And it is not going to wait for the function to be getting successfully completed. It just triggers the Lambda function. Anyway, we are going to see that particular uh, 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 thing as per the S3. Just let me just go here and put that particular command. Will in the chat. Let me put this one for everyone. This is the command, guys, and you need to change the bucket name. Sorry, function name there, and the region where you have deployed your function. If that part, just go to your Cloud Shell and execute it. That's it. Okay. Even though your function is getting throwing an error, how to make the function through to throw an error instead of this one? Just let me make this return. Okay, just let me put return exception, EXCEPTION, return exception. And just let me just something went wrong. Something wrong. Okay, something like this. Okay, that's what it is. WRONG or not working. Something not working. Not working. Something like this. Okay, you can just make that one happen actually. So okay, that's what it is, guys. So what we can do, one more thing we can do is, I want to configure my local CLI. Let me stop sharing my screen and configure my local CLI. And we can trigger the Lambda function from my local CLI as well. That means from my local command prompt item. So let me stop sharing my screen because I need to fetch out the access keys and secret access key from somewhere else. Okay, I don't want to make that to be visible, guys. Sorry for that. But yeah, let me just not sure whether that will work, but yeah, if that is working, then that will be great. No, no. One second, let me just go there. Okay, let me just create the access keys immediately. Okay, let me go to this place. And I'm not sharing my screen, please do understand. Okay, because it's the security reasons. So, you know, this option, create an access key, AWS CLR. I understand. I'll just let me click on next. Just let me click on create an access key and just go here and AWS configure. Okay, click on that, give an access key and provide the secret access key and put it here and just put it up. So AWS LS, let me just get the state location. Yeah, it is working. Now let me clear the screen. I would like to share my screen now. Okay, so I have configured my access key and secret access key. Just let me share my screen, guys. Okay, I hope my screen is again visible. Okay, okay. Now let me just go here. And my function name is, what is my function name that you can see that here? Start here is the AWS, and let me just put the Lambda. Where is that Lambda? Let me search for Lambda. Search on that. Let me click on async CLI, ASYNC hyphen CLI. Let me just go to this particular place. And you can see that here async CLI is a function name, and the region where my Lambda function exists is North Virginia. And you can just click on that. And let me make this function to be successful first, and then I'll be making this function to be failure. Okay, so just let me remove this exception. Okay, let me comment out this part. Okay, for example, this one. Okay, and just let me make this to be executed successfully, deployed. That is going to be deployed successfully. Fine. Okay, so yeah, we are invoking the Lambda function, guys. Okay, just copying this particular Lambda function, and we are just invoking it. We are not going to wait for the response. Okay, just let me click on go to the terminal and put this one here and let me click on enter. So you can see that here status code 202. Okay, that means it is successfully executed. It is saying, okay, that's what it is. We have triggered the Lambda function. That's it. We are not waiting for the response from the like whatever it is giving. You can see that here. This is the response that should give, but it is not giving because we are not waiting for the response. Actually, that's what it is. Okay. Now let's make this to be failed. Actually, okay. You can see that here. Let's like uncomment this one. So generally, this is going to be failed, guys. If you test this, okay. If you test this, you can create an event and just let me give this event name as test save. And if you test this actually, so it is going to throw you an exception. You can see that here, runtime exception and all those things. It is going to throw you an exception. Okay, but even though you execute this one from your local CLI, you can just click on enter. You can see that here it is still giving 202. Okay, that means that my CLI is not caring about whether the Lambda function is successful or not. It is just triggering the Lambda function, and that's it. It is not doing anything other than that. It is triggering the Lambda function, and Lambda function can fail. Lambda function can be successfully executed. This is something called asynchronous execution. This is we are asynchronously triggering the Lambda function. That's what you need to understand from the point. That's what you need to understand from the point. We are asynchronously triggering the Lambda function. That's the point, guys. Okay, that's how it is. Is this scenario clear for everyone? Is this scenario clear for everyone? Yeah, Sairaj, we have a lot of things which we can use. Okay, but yeah, I've used the access keys and secret access key. That's it. So that is also asynchronously invoked. Lambda function can be asynchronously invoked with multiple services. Okay. So for example, it can be S3 bucket, it can be CloudWatch events, it can be SQSQ, SNS topic, whatever it is. They are asynchronously invoked. Okay. Multiple services can asynchronously invoke Lambda function. Okay, that's what it is. Okay. Now what we'll do? Now we will be configuring this particular architecture. This okay. Instead of uh, just see this architecture that we have drawn wherever it is, where we have drawn actually. So where it is. Okay, so this is the one. So I'm just triggering the Lambda function from the CLI, and I'm going to create the SQS I'm going to configure the retries for the Lambda function. If the retries is also not successful, it is going to trigger the SPS queue. It's going to send the event to the SPS queue, guys. That's what you need to understand from the point. Okay. Uh, 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 For the alerting, we use asynchronous invocations. Okay. For the message queues, we use asynchronous invocations. Okay. That's what you need to understand from the point. Okay. So let me just go here. What I'll do, I will go to the configuration. I'll just create a SQS queue, guys. SQS. SQS. Okay. For example, this one. Okay. Just let me go here. SQS queue. Let me go to the SQS queue and just create a SQS queue for you. Okay. Okay, let me click on create SPS queue. One second, please, sir. Okay, let me click on queue. Okay, so just let me lambda error invoke invoke error queue actually. Okay, that's what it is. I'm just let me. I'm not thinking of any configuration here. We are not considering on SQS queue actually. So this I'm creating a queue. That's it. Okay, so this is a queue that I have created. Let me go to my Lambda function and just let me go to the configuration that I have. You can see that here asynchronous invocation. We have something called a tab called asynchronous invocation. That means after retry attempts two, I need to send that event to the SQS queue. That's what you need to understand from the point. This is the SQS. You can also send to the SNS, but I'm going to send the SQS. And the queue is going to be this one, invoke Lambda error. It is going to throw me the error. I think so. Yeah, you can see that here. It is going to throw me the error because Lambda function, to send to the messages to the SQS queue, it should have the permissions. So what I'll do, you need to just update the IAM role attached to this Lambda function to have the permissions of the SQS queue, guys. Okay, let me just go there, update the IAM role. Okay, click on add permissions, attach policies, SQS full access. Let me give this one and let me click on add permissions, guys. And you can now go to your Lambda function. Okay, whatever it is, this one, and let me click on save. Okay, your Lambda function is going to be saved now. So now you are sending these are dead letter queue. That means whenever the retries have been attempted and the messages will be sent to the dead letter queue. If you go to your queue, where is your queue actually? So this is the queue that you have, right? So you can click on send and receive messages. Click on that, guys, and you will be just hold for messages. As of now, there are you can see that here there are no messages that have been there. Here we can just very clearly see that there are no messages that are being there in this particular queue actually. So now what we'll do, we'll make this Lambda function to be triggered, and Lambda function is going to retry for the number of retries that you have mentioned here, retry attempts, that is two. And that if that is being failure, the message that you'll be seeing as part of this SQS queue, guys, soon. Okay, you'll be seeing that here. As of now, there is no messages in the queue because the queue has received none of the messages. You can see that here very clearly. And just let me trigger the Lambda function one more time. Okay, let me just go here, put that one here. And my Lambda function is going to throw an error because why? I have made the Lambda function to throw an error by making the Lambda function to raise an exception. Okay, that's what it is. Okay, just that's it. Okay, always if it retried also, the Lambda function retries also, my Lambda function is going to be throwing an error. Okay, that's what it is. And let me just click on, if it is already deployed, that's fine. Actually, let me just go to my terminal, and let me click on enter, guys. Okay, this request which you are making, it is an asynchronous invocation, because even though that is be getting failed, it is returning for us two, not two. Okay, that's what it is, right? So it is getting failed. Actually, it will be definitely failed. How you can see that it will be definitely failed? Through the CloudWatch logs. Actually, you can just uh, yeah, you can also see that here in that particular place. You can just or else you can just go to the what is that, invocations actually. So you can just go to the CloudWatch log groups, wherever it is. You CloudWatch log groups. You can just go there, and you will be able to see the logs, guys, in this particular place. Okay, just let me see this. Let me show you that here. You can see that it is error. Okay, it's a runtime error. It's an exception that is being drawn, guys. And let me go to my SQS queue and let me poll for the messages. After number of retries, the message should be displayed here. Okay, let's go. You can see two times error has been occurred. That means two times retry has been done. Soon there should be some error here. Yeah, just let me click on another time, hold for messages. Come on, what happened? Let me refresh this one. And let me click on poll for messages one more time. Hmm, why there is no message? It should send the message. Should be soon. 1 second. So I will configure right way. Lambda invoke error queue. That's what we are seeing, right? So let me just go here. Lambda invoke error queue. That's what it is. And just let me just delete this all for messages. Yeah, you can see that here. This is a message that has been come. It is taking some time. That's fine. You can just click on this one and just you can see that here message ID and attributes. This is a body that we have passed from our invocation. You can see that here key one value, one key two value, two key three value. Two. That's what are passed actually, and these are the attributes. Okay, the request ID and error message. You can see that very clearly this one and the error code actually, and you can see the details of that actually. So this is the message. After this number of retries, the message will be put as part of this SQS queue, and from the SQS queue, the consumers can consume and fix the issue, whatever the issue that we will be having. Actually, that's what it is. Okay. Now let's move forward, guys. Okay. I think our time got finished, but yeah, let's just give me some time because I need to discuss two things. Okay, that's what it is, and let's move with the security, guys. Okay, for example, let's deal with the security now. Okay, you have your Lambda function. Let's say have your Lambda function. Okay, and this is the Lambda function that you are going to have this LAMBDA Lambda function. Suppose if this Lambda function is accessing something here, Lambda function is accessing the SQS queue. Just recently, just now we have seen this Lambda function is getting access, like accessing the access. This Lambda function is accessing the SQS queue, right? This is a SQS queue. So if Lambda function is accessing the SQS queue, you need to update the IAM role that is attached to the Lambda function with the permissions of the SQS. Okay, just understand. If Lambda function is accessing some other service in AWS, you need to update the IAM role that is attached to this Lambda function, and in order to access the SQS queue actually. So, but If some other service is accessing the Lambda function, suppose let's say S3 bucket is accessing the Lambda function. If some other service, okay, S3 bucket is want to trigger the Lambda function, S3 bucket, okay. If S3 bucket want to trigger the Lambda function, okay. If the S3 bucket want to trigger the Lambda function, Lambda function should allow to trigger itself. How the Lambda function should allow to trigger itself? Using resource-based policy. If the S3 bucket want to trigger the Lambda function should allow to trigger the S3 bucket. That you need to allow using resource-based BASED policy, guys. Resource-based policy. And if Lambda function want to connect to the other services in AWS, Lambda function IAM role should be updated. Lambda function IAM role should be updated with the permissions that the Lambda function want to access to other services actually. So IAM role, IAM role updation, IAM role update is required. Update update is required. That's what you need to understand from the point. Okay, so this is how the security works in Lambda. Just if you go to that particular Lambda function, you just go to the Lambda function, you can just go to the configuration and you just need to click on the permissions and you will be having something called role. Okay, what is this? When is this role used? If the Lambda function want to communicate with other service like SQSQ, you need to update the role. But if someone want to trigger the Lambda function, you need to update the resource-based policy. Here, no one is triggering the Lambda function. In our previous Lambda function, if you just go to the sync load balancer, if you just go to the monitor configuration and the permissions, there, the target group is triggering the Lambda function, right? Lambda function should be allowed. Function should allow the target group to trigger itself. That is why you will be seeing that here, resource-based policy, that Lambda function is allowing the target group to trigger this Lambda function. I hope you got the clarity when to use resource-based policy and when to use IAM roles. Actually, that's what the security reasons that you need to understand from the point. Actually, that's what the thing is with respect to security. Okay, is this clear, guys? Is this clear? Okay. So now let's just like, I know that time has been finished because our agenda did not finish, guys. But yeah, just we'll be discussing few points and just we'll be leaving our session and we'll be continuing with this session. Okay, I'll talk to the management, and if the management accepts, I'll be continuing with this session in the next week as well with the webinar on this particular Lambda, so that you can join that particular session as well. Okay, we need to discuss few things about the Lambda, very important topics. But yeah, I'll be just explaining few configurations before closing those, and I'll take some Q&A from you people. Okay, the thing is, the few configuration is, just let me go to the general configuration. So you can just see here, you can click on edit. Okay, so you can set for each function, for you can set the memory size as from 128 MB, as from 128 minimum you need to set 128 MB, and until 10 GB or 10,240 MB of size memory that you can set. That's what you need to understand from the point. Okay. Now the execution time of the Lambda function should be not more than 15 minutes. If the execution time of the Lambda function is more than 15 minutes, you should not use Lambda function also. You can see that here, Lambda function is, this is the Lambda function. This is the Lambda function is being configured to execute, to be complete its execution within 3 seconds. Okay, if the Lambda function is taking time, okay, to execute more than 3 seconds, then the Lambda function will be timed out. Actually, let me just show you actually. So let me just go here to the code, and let me just, what I'll do, let me just wait, let the code be loaded. Okay, this is the what? and let me import the code, import time, guys. There is something library called time. Actually, I would like to time dot sleep, sleep. Okay, sleep. I am just making the Lambda function to be executed more than 3 seconds because we have configured this Lambda function to execute within 3 seconds. Okay, I'm making this Lambda function to execute more than 3 seconds so that we'll be understanding, okay, what will happen if the Lambda function executes more than 3 seconds because we have configured this function to be executed within 3 seconds. Let me just click on deploy, guys, and let it deploy, and let me trigger the Lambda function one more time. Let me test it. Okay, let me click on test. Actually, you can just see that here execution started within 5 seconds, and you can see that here you can very clearly see that uh, uh, your duration is 3 seconds, and build it has been executed. It is trying to execute more than 3 seconds. That is why you can see that here it is the failed state. You can see here sandbox timed out. That means Lambda function is configured to execute within 3 seconds, guys. Within 3 seconds. Timeout is 3 seconds. If the Lambda function is trying to execute more than 3 seconds, what will happen? It will be timed out. It will be throwing an error. So you need to make sure that your Lambda function, you have configured the right amount of timeout so that it will not be going into the timeout state. Actually, that's what you need to understand from the point. Okay, so that's one of the configuration that you need to understand. So there are some other configurations. There is something called concurrency and reserved concurrency, provisioned concurrency, and multiple things. Deploying the Lambda function into the VPC and the function URL and the destinations and multiple environmental variables and triggers. Triggers is this one only. Triggers is whenever Lambda function is getting triggered by some other things. Actually, you can see here the application load balancer. That's a trigger. Okay, for the Lambda function. But okay, sure. So ephemeral storage means that storage will be there within the, like, that's a temporary storage. Okay, I'll be explaining not now actually because it's already time. Okay, it's been time has been completed of the webinar. But yeah, definitely we will be continuing this session. I'll be talking to the management if they can schedule one more session for the Lambda so that we'll be talking about this. And it's not a developer's concept, Sairaj. Okay, Lambda is purely like the code which you are writing in the Lambda function. Okay, some most of the times it belongs to the DevOps only. Okay, the code which you are writing in the Lambda function, most of the times it belongs to the DevOps only. Okay, so please do understand. It's not a developer concept. It's managed by DevOps, and it is being completely managed by DevOps and all those things. So you need to understand that point. But the development, sometimes the people uh, deploys their application code as part of the Lambda function because to reduce their costs actually. So the development of the code in that cases, the development of the code belongs to the developer. But all other than that, deployment, configuration of the Lambda function, and making the Lambda function to be increasing with its performance, and all those things, you are the one who is going to manage as a DevOps engineer. The developers only develop the code. That's it. Other part is going to be done by you. Okay, that's what it is. That's a thing. Like, I hope the session is meaningful for you, right? I hope the session has given some new things into your plate, actually. So, anyone have any questions, guys? Anything? Yeah, you can just zip that file, uh, Diana, Samal, and you can just import that particular zip to this particular function, please. That's how you need to import the application code to the Lambda function. Yeah. Any questions or anything? Any? Okay. We did not use the S3 because I have just invoked in an async Lambda function got invoked in an asynchronous way through the CLI actually, but you can use the S3 as well too. asynchronously invoke the Lambda function. Okay. Uh, no, no, I'm talking about the workshop, Yuvraj, not the course. Which one? Which one was seen? Is it a one-time implementation or we have to change based on the different environments? If you have a different code for the different environments, you need to change it. Okay. Of if you have same code across the environments of the Lambda function, you need to just uh, yeah. Yes, it will be uploaded to the YouTube. Yeah, I know that, bro. I know that. So it will be started at some after 10 minutes, right? So yeah, yes. Okay. Thank you, guys. This session will be there as per the YouTube as well. You can, in your free time, you can also watch. Okay. So thank you for your time on this Sunday. And we'll meet in the next class, in the next workshop. Thank you. Bye.